The sky above Europe looked peaceful from the ground. Miles above the frozen clouds, silver aircraft carved thin white scars across the atmosphere while distant engines echoed like thunder trapped inside metal. Civilians looked upward with admiration. Newspapers called these machines the future of warfare. Governments called them miracles of engineering. But the pilots who flew them knew a terrifying truth. Some airplanes were more dangerous than the enemy. In the winter of 1943, Allied and Axis engineers were locked in a race that had become almost desperate. Whoever controlled the skies would control the war itself. Bombers were climbing higher. Fighters were becoming faster. Every nation wanted an aircraft that could outperform anything the enemy could launch. And speed came at a terrible price. Aircraft designers pushed engines beyond limits nobody fully understood. Horsepower increased so rapidly that mechanics could barely keep the machines alive between missions. New fuels were tested. Experimental cooling systems appeared. Superchargers screamed at altitudes human beings were never meant to survive in. Pilots became test subjects inside flying laboratories. At first, the experimental liquid-cooled engine looked like a masterpiece. It promised unmatched high-altitude performance. Engineers claimed it would allow aircraft to climb faster, fly farther, and intercept enemy bombers before they could strike cities below. Compared to older air-cooled engines, the design appeared sleek and modern. Liquid cooling reduced drag. The aircraft looked elegant in the sky. But hidden beneath the polished metal skin was a nightmare. The engine ran incredibly hot. At low altitude, mechanics could usually keep temperatures under control. But at 30,000 feet, conditions changed violently. Superchargers forced the engine to work harder than ever before. Fuel mixtures became unstable. Coolant pressure skyrocketed. Inside the cockpit, pilots began reporting strange heat. Not warmth. A natural heat. The cockpit floors grew hot enough to burn through gloves. Metal panels radiated warmth into pilots' legs and chests. Some described the air itself becoming difficult to breathe. At first, commanders blamed pilot stress. War was exhausting. Men flew repeated combat missions with little sleep. Many officers dismissed the complaints as exaggeration. A few even accused crews of inventing stories to avoid high-altitude operations. Then the emergency landings began. One aircraft returned with its cockpit canopy fogged entirely from the inside. Ground crews opened the hatch and found the pilot barely conscious, drenched in sweat despite temperatures below freezing outside. Another pilot landed unable to move his right hand. The control stick had become so hot during flight that the skin on his glove partially melted into the metal. Then came the deaths. One fighter disappeared from radar without transmitting a distress signal. Search crews later discovered the wreckage scattered across a frozen hillside. Investigators initially believed enemy fire had destroyed the aircraft. But there were no bullet holes. No signs of combat. The engine had catastrophically overheated. Witnesses claimed steam burst from the aircraft moments before it entered a fatal dive. Soon rumors spread through entire squadrons. Pilots whispered about the boiling cockpit. Some airmen believed the aircraft was cursed. Others refused to fly it unless ordered directly by senior command. Mechanics worked through nights searching for faults they could never consistently reproduce on the ground. The terrifying part was how random it seemed. One flight would operate perfectly. The next became a death trap. The engine's liquid cooling system relied on pressurized coolant circulating through extremely hot engine components. Under certain high-altitude conditions, pressure fluctuations caused coolant to flash into steam inside the lines. And those lines often ran dangerously close to the cockpit. When failures occurred, temperatures inside the aircraft could rise within seconds. Steam leaked into pilot compartments. Insulation failed. Metal surfaces radiated unbearable heat. At high altitude, where outside air temperatures were far below freezing, crews suddenly found themselves trapped inside flying furnaces. Pilots opened ventilation systems desperately trying to cool the cockpit, but thin air at 30,000 feet provided little relief. Oxygen masks fogged. Sweat-soaked flight suits. Some men became dizzy from dehydration and heat stress before they even realized what was happening. Others lost consciousness entirely. The military tried to hide the incidents. Official reports blamed mechanical unreliability, pilot error, or combat damage. Engineers feared public embarrassment. Governments feared losing morale. Experimental aircraft programs represented national pride. Admitting that an advanced fighter plane could literally cook its own pilot alive was unacceptable. So the flights continued. Young airmen climbed into those cockpits knowing the stories might be true. Most pilots during World War II were barely older than boys. Many had grown up dreaming about aviation after seeing air races and newspaper photos during the 1930s. Flying represented freedom, heroism, adventure. Now those same men sat surrounded by boiling coolant lines and overheated engines while climbing into thin oxygen-starved skies over Europe. Some wrote letters home before missions. Others carried lucky charms into combat. A few quietly wondered whether enemy bullets might be kinder than what waited inside their own aircraft. The fear became psychological as much as physical. Every strange vibration triggered panic. Every rise in temperature made pilots glance nervously at gauges. Every faint smell of burning fluid sent adrenaline surging through exhausted bodies already pushed beyond human endurance. Combat itself became secondary. Pilots worried more about surviving the engine than surviving enemy fighters. And yet the aircraft remained astonishingly effective when it worked correctly. That was the tragedy. The engine delivered incredible speed and climbing performance. In combat, it could outperform many rival aircraft. Test pilots praised its raw power. Military officials believed it represented the future of aerial warfare. Engineers became trapped by their own ambition. Instead of abandoning the design, they tried to patch the flaws. Additional insulation was installed. Coolant systems were modified. Emergency procedures were rewritten. Pilots received instructions on how to descend rapidly if overheating occurred. But war leaves little time for perfection. Aircraft were desperately needed immediately. Factories continued production. Squadrons continued flying. And somewhere high above the clouds, more cockpits became ovens in the sky. One pilot later described the sensation in horrifying detail. He said the heat arrived slowly at first, almost unnoticed beneath heavy flight gear. Then suddenly it intensified until breathing itself felt painful. Steam blurred his vision. Perspiration filled his goggles. He could smell heated rubber and burning electrical wiring while trying to maintain formation beside bombers crossing enemy territory. Outside the aircraft, temperatures were nearly 60 degrees below freezing. Inside, he thought he was going to die from heat. His radio transmission ended abruptly moments later. The aircraft survived. The pilot did not. Stories like that spread quickly through wartime airfields. Ground crews watched exhausted men climb from aircraft with faces pale from dehydration. Medics treated burns, heat exhaustion, and oxygen deprivation simultaneously. Some returning pilots could barely stand after landing. Yet official explanations remained vague. Mechanical complications. High-altitude operational stress. Cooling irregularities. The language sounded clean and technical. Reality was not. Reality involved terrified young men trapped inside overheated cockpits thousands of feet above enemy territory with nowhere to escape. No parachute could save them at those speeds and altitudes if they blacked out first. No rescue aircraft could reach them in time. And no amount of bravery could stop boiling coolant from turning a cockpit into a death chamber. The war demanded results, not caution. So the missions continued. Every dawn, mechanics prepared aircraft beside freezing runways while pilots received briefings beneath dim lights and cigarette smoke. Maps covered tables. Weather officers warned about conditions above the clouds. Nobody talked openly about the overheating anymore. But everyone thought about it, especially during climbs. Because that was when the engine became most dangerous. Higher altitude meant greater strain. More supercharger pressure. More heat. More chances for the cooling system to fail. Pilots watched temperature gauges obsessively while climbing through clouds toward operational altitude. Some men claimed they could sense disaster before warning lights appeared. A strange vibration. A faint hiss. The smell of hot metal. Then panic. The experimental engine designed to dominate the skies had become one of the most feared machines of the war. Not because it lacked power. Because it had too much. And at 30,000 feet above Europe, trapped inside aluminum cockpits surrounded by boiling machinery, pilots discovered something terrifying. Sometimes the deadliest weapon in the sky was the one bolted directly in front of them. The worst missions always began before sunrise. Airfields across Europe came alive in darkness. Floodlights cut through fog while mechanics moved between aircraft with oil-stained gloves and exhausted eyes. The smell of fuel mixed with cigarette smoke and frozen mud. Somewhere in the distance, engines coughed awake one after another like metal beasts preparing to hunt. Pilots arrived quietly. Some joked to hide fear. Others said almost nothing at all. By 1944, experienced airmen understood something civilians never could. The most dangerous part of war was often the uncertainty. Enemy fighters could be anticipated. Anti-aircraft guns could be avoided. But mechanical failure was unpredictable. and the experimental liquid-cooled engine had earned a reputation that terrified entire squadrons. Ground crews had begun noticing alarming patterns. Aircraft returning from high-altitude escort missions showed warped cockpit panels. Paint blistered near engine compartments. Rubber seals cracked from extreme temperatures. Some canopies fogged permanently from internal heat exposure. Mechanics tried everything. They flushed coolant systems repeatedly, replaced pressure valves, reinforced coolant lines with additional shielding, modified airflow vents around the engine housing. Nothing solved the problem completely. The overheating appeared randomly, almost like the aircraft itself chose its victims. One pilot could complete 5 missions without issue. Another would experience catastrophic cockpit temperatures during his very first flight. Military command refused to halt operations. The engine's performance remained too valuable. Enemy bombers were flying higher than ever before, and older aircraft struggled to intercept them. This experimental engine gave pilots the speed and climb rate needed to reach those altitudes quickly. On paper, it was revolutionary. In reality, it was unstable. The physics behind the disaster were brutally simple. At extreme altitude, the engine's supercharger compressed thin air into the cylinders at enormous pressure. This generated massive heat. The liquid cooling system was supposed to absorb that heat and circulate it safely away from the engine. But under sustained stress, coolant temperatures sometimes exceeded safe pressure limits. When that happened, parts of the coolant system could flash into steam. Steam inside a pressurized aircraft engine was catastrophic. Pressure spikes shook the cooling lines violently. Valves failed. Hot coolant escaped into compartments surrounding the cockpit. Insulation designed for ordinary engine temperatures suddenly became useless. And because wartime aircraft prioritized speed over crew comfort, the cockpit sat dangerously close to the engine itself. Pilots were separated from mechanical hell by only thin sheets of metal. One squadron commander later admitted that airmen had started carrying extra water bottles not for survival after crashes, but because cockpit temperatures during certain flights became unbearable. Men drank constantly during climbs. Some poured water onto gloves just to hold the controls. Others loosened flight suits despite freezing temperatures outside. Then came the mission that changed everything. A formation of fighters received orders to escort bombers deep into occupied territory. Weather conditions were brutal. Temperatures above the clouds reached deadly lows, forcing engines to work harder than normal. The formation disappeared into thick cloud shortly after takeoff, climbing steadily toward operational altitude. Frost spread across cockpit glass while propellers cut through the frozen sky with violent force. The aircraft looked powerful from a distance, sleek, fast, unstoppable. Inside the cockpits, the reality was very different. Temperature needles slowly crept upward. Pilots watched them constantly. At first, nobody spoke over the radio. Veteran airmen had learned not to panic too early. These engines often ran hot during climbs. Sometimes the gauges stabilized once the aircraft leveled out. Sometimes they did not. At nearly 30,000 feet, one fighter suddenly drifted out of formation. The pilot reported intense heat flooding through the cockpit floor. Another airman complained that steam was forming around his instrument panel. Then came shouting. A pilot near the rear of the escort group yelled that he could barely touch the controls anymore. His oxygen mask fogged completely while warning lights flashed across the cockpit. Seconds later, his transmission ended in static. The aircraft vanished into the clouds below. The rest of the formation continued forward because wartime missions allowed no hesitation. But every surviving pilot understood something terrifying in that moment. The enemy was no longer the only thing trying to kill them. By the final years of the war, stories about the overheating aircraft had spread far beyond individual squadrons. Pilots talked quietly in mess halls after missions. Mechanics exchanged rumors while repairing damaged engines late into the night. Even commanders who publicly defended the aircraft privately admitted its dangers. But the war machine could not stop moving. Too much money had already been invested. Too many factories were producing parts. Too many missions depended on speed at high altitude. And so the aircraft continued flying. That was one of the darkest realities of World War II engineering. Nations were racing so desperately for technological superiority that dangerous flaws were sometimes accepted as unavoidable. If a machine gave even a slight advantage in combat, military leaders often considered the risks worthwhile. Pilots rarely had a choice. Orders arrived. Engines started. Aircraft climbed back into the sky. Many of the young men flying those missions understood they were part of an unfinished experiment. Wartime innovation moved faster than safety testing ever could. Engineers designed machines under enormous pressure while governments demanded immediate results from weapons nobody fully understood yet. The liquid-cooled engine represented that desperation perfectly. On paper it was brilliant. The engine allowed aircraft to fly faster and higher than many older designs. Its streamlined shape reduced drag. Its supercharger produced enormous power at altitude. In ideal conditions, the aircraft could outperform enemy fighters and intercept bombers with frightening efficiency. But pushing technology beyond its limits created consequences no blueprint could fully predict. The overheating problem never disappeared entirely. Some engineers believed the issue came from coolant pressure instability during long climbs. Others blamed flaws in airflow design around the engine housing. A few argued that wartime fuel quality varied too much between airfields, causing unpredictable temperature spikes under combat conditions. No single explanation solved everything, and every attempted fix introduced new risks. Additional armor increased aircraft weight. Extra ventilation reduced aerodynamic performance. Stronger coolant pressure sometimes made steam explosions even worse when failures occurred. The aircraft became trapped in a cycle of compromise. Fast enough to remain valuable. Dangerous enough to terrify its own crews. One former mechanic later described opening an engine compartment after a high-altitude mission and feeling heat pour outward like an oven door opening. He claimed some coolant lines glowed faintly after landing while the metal around the cockpit remained too hot to touch for several minutes. Pilots developed routines to survive. Some loosened gloves before takeoff so they could remove them quickly if cockpit temperatures rose. Others carried extra cloth inside their jackets to wrap around overheated controls. Veteran airmen memorized emergency descent procedures so thoroughly that they could perform them almost automatically while half blinded by steam or sweat. But preparation could only do so much. At 30,000 feet, small failures became deadly within seconds. A single ruptured coolant line. One failed valve. One sudden pressure spike. That was all it took. The human body was never designed for such extremes. Pilots already faced freezing temperatures, oxygen deprivation, violent turbulence, exhaustion, and enemy fire during every mission. Adding unbearable cockpit heat created conditions that pushed airmen beyond physical limits. Some lost consciousness. Some panicked. Some never even transmitted distress calls. And because many crashes occurred over enemy territory or deep cloud cover, the true number of overheating-related deaths may never have been fully recorded. Official wartime reports often hid embarrassing mechanical failures beneath vague language. Operational complications. Engine malfunction. Pilot lost during escort mission. Simple phrases covering horrific realities. For decades after the war, many of these stories remained buried beneath larger histories about famous battles and aircraft victories. History tends to celebrate successful machines, not flawed ones. Museums display sleek fighters beneath bright lights while visitors admire engineering achievements and combat records. Few people imagine the fear inside those cockpits. Few picture pilots sweating through flight suits while ice formed outside the canopy. Few understand how terrifying it must have felt to realize the heat was rising faster than the aircraft could descend. Yet those experiences were real. And they reveal something important about wartime innovation. Technology does not become dangerous only when it fails completely. Sometimes the most dangerous machines are the ones that almost work perfectly. That aircraft was fast enough to stay in service. Powerful enough to remain useful. Effective enough that commanders kept sending pilots into the sky despite the risks. In another timeline, during peacetime testing, the engine might have been redesigned slowly and safely over several years. Engineers could have grounded the aircraft until every overheating issue was solved completely. World War II did not allow time for patience. The skies over Europe had become a giant laboratory fueled by desperation. Young men paid the price for every unfinished design. And despite everything, many pilots still loved flying. That may be the strangest part of all. Even after witnessing overheating disasters, even after hearing stories about steam-filled cockpits and fatal dives through clouds, countless airmen climbed back into those aircraft willingly. Some trusted their skill. Others trusted luck. A few simply accepted fear as part of survival. Because during wartime, courage often meant continuing despite knowing exactly how bad things could become. As the war finally approached its end, newer engine technologies slowly replaced many of the dangerous experimental systems that had caused so many problems earlier in the conflict. Jet aircraft began changing aviation forever. Cooling systems improved. Materials became stronger. Engineering standards evolved through lessons written in blood and fire. But the legacy of those engines never truly disappeared. Modern aviation safety regulations exist partly because earlier generations learned hard lessons the brutal way. Every emergency procedure, every redundant system, every cockpit temperature warning in modern aircraft traces back to disasters engineers never wanted repeated. The pilots who flew those overheating fighters helped expose dangers future generations would avoid. Many never received recognition for it. Their stories survived mostly in maintenance reports, squadron rumors, and fragmented wartime memories shared decades later by aging veterans who still remembered the heat. The unbearable heat. Heat inside freezing skies. Heat inside aircraft designed to conquer altitude. Heat powerful enough to turn advanced war machines into flying death chambers. Today, when restored World War II fighters appear at air shows, crowds look upward in admiration as polished engines roar across the sky once again. The aircraft seem heroic. Beautiful. Almost immortal. But hidden behind that beauty is another truth. Some of those machines terrified the very men who flew them. Because somewhere above the clouds during World War II, long before modern safety systems existed, pilots discovered something horrifying. Sometimes the deadliest thing in the sky wasn't enemy fire. It was the engine mounted directly in front of them.